Our goal is to harness electrical energy by getting electrons to move through our circuit. But how do we get the electrons to move? First, we need to build our circuit out of the right materials. For example, here's some copper wire. When you want to get electrons moving, copper is a great material to use for your circuit. And I want to show you why that's the case.
So this is the atom we looked at earlier. And here's an atom of copper. Now, it's bigger and more complex, but we can ignore all of that for now. What we're interested in is just this one outermost electron. And the interesting thing about this electron is that it's relatively easy to get it to move around and even go from one copper atom to another. So suppose we have a few different copper atoms all sitting next to each other, and they all have these outermost electrons, which are kind of loose electrons. The copper atoms are not holding on to them very strongly. So what we can do is we can put something on one side that has a strong positive charge. And then we can put something on the other side that has a strong negative charge. Now, we'll talk about where these positive and negative charges come from in a minute. But remember, opposite charges attract. So the positive charge will tend to attract the electron that is close to it. And like charges repel. So the negative charge on the other end will tend to repel the electron that it's next to, which will then repel the next electron in line, and so on. And so the electrons are pulled from one end and pushed from the other, and the result is that we start to get a flow from one copper atom to the next.
If we put a bunch of copper atoms together, we can get copper wire. Because copper has relatively loosely held electrons, and we can get those electrons to flow pretty easily, we say that copper is a good conductor. A conductor is just any material that allows charges to flow. In contrast, some materials are what we would call insulators. These are materials through which it is difficult for charges to flow. For example, plastic tends to be a good insulator, and that's why you'll often see wires wrapped in plastic. We want charges to flow through the wire in the center, but we use the plastic to prevent charges from flowing in ways we don't want them to, like from the wire and into your hand.
So imagine that we have a piece of copper wire. And like we just saw, the copper atoms in this wire have all those loose electrons. But they're not flowing through the wire yet. They're more or less just sitting there. To get them moving, we need to place a positive charge at one end of the wire and a negative charge at the other. And one way we can do that is by taking the two ends of our wire and connecting them to a battery.
You've probably noticed that batteries have a positive end and a negative end. Now, inside the battery, there are chemical processes that collect positively charged particles at one end and negatively charged particles at the other. Remember, opposite charges attract, while like charges repel.
So the positively charged end of the battery will pull electrons toward it, and the negatively charged end of the battery will push electrons away from it. And the result is that we'll start to get a flow of electrons through the copper wire. Now let's pick a point in our wire and zoom in on that flow of electrons. And if we were to sit at this point and count how many electrons go by, we would see that a certain number of them go by each second. We call this the current. To be exact, current is measured as the number of charges flowing through a given location per second. So if we sit at this point and we count the number of electrons that go by each second, that tells us the current that's flowing through the wire. To get a current, we need to have a difference in charge, and that's created by the two ends of the battery. The wire must connect back to the battery, or whatever the power source is, for current to flow. If we disconnect one end of the wire, or if there's a break anywhere in the wire, current will no longer flow. Put another way, we must have a closed loop. And that's essentially the definition of a circuit. It's a closed loop through which charges can flow.
And so by setting up a closed path and using a power source, like a battery, to create a difference in charge, we can get electrons flowing through our circuit. And this flow, this movement, gives us the opportunity to harness the energy of those moving electrons to do useful work, like turning on our light bulb.